Welcome to the channel, everybody, and today we're starting a new series. It's called Let's Learn Arduino, yeah. Obviously, I'm a beginner. So I just got myself one of these, a used one from a friend. She completed a few of these projects and then got bored, I think. And then she asked me if I would want it, and I said, hey, hell yeah. So unfortunately, my webcam isn't working right now, so I just thought I'd do the introduction without the webcam, so I'm prepared. Right, so right out of the box we have a guide, a projects book, which includes details about these 15 projects. So what is Arduino? Arduino is an open source electronics platform based on easy to use hardware and software. So basically, you know, it's a microchip, I think, right? It has lots of different inputs and outputs, and I think you can even add, I forgot what they were called. There's a special name for it. I forgot, but you can add more functionality to it. Mine is pretty old. It's called Genuino. I think they separated a while ago and now they're together again, Genuino and Arduino. So I have an Arduino 1 starter kit. It's probably the same. Yeah, it looks pretty similar. Right, so Arduino boards are able to read inputs, light on a sensor, finger on a button or a Twitter message, and turn it into an output, activating a motor, turning on an LED, publishing something online, etc. So it's pretty cool, actually. You know, there's a lot of things you can do, and there are a lot of projects online. So I guess it makes sense to start with the basic examples, and then we'll continue learning from there. Yeah, the boards are pretty inexpensive. Of course, there are even cheaper microcontrollers, but you know, this is pretty easy to learn, and there's lots of functionality and examples online. Apparently, it's cross-platform, so I just saw that. I think when this Genuino 1 starter kit came out, the only option was to install the IDE, but right now apparently you don't even have to install it. Apparently it's open source. Yeah, so let's dive in. Right, one important question I had in mind is what language does the Arduino use? So apparently it's a subsection of C, C++ functions. And of course there are, you know, you can probably also use Python or something, but then you would probably need something else, a compiler or something. I think I saw that before, but right now I don't know too much about that. Right, so the board looks like this. Let's take a quick look. Number 1 is the digital pins. Use these pins with digital read, digital write, and analog write. Analog write works only on the pins with the PWM symbol. Pin 13 LED is right here. The only actuator built into your board. Besides being a handy target for your first blink sketch, this LED is very useful for debugging. Okay, so I guess it's an LED that's always on the board. Power LED and that you can control. Power LED indicates that your Genuino is receiving power, useful for debugging. 4. This thing here is a microcontroller. Okay, so the Genuino board is not a microcontroller. It's a board with an ATmega microcontroller. Alright, it's good to know. 5. Analog in. Use these pins with analog read, I guess to, you know, connect it to other hardware. 6. GND and ground, I guess, and 5-volt pins. Number 6, right. Use these pins to provide 5-volt power and ground to your circuits. 7 is power connector. Right, I can see that on my Genuino as well. So that's the power connector. TX and RX LEDs here. These LEDs indicate communication between your Genuino and your computer. Expect them to flicker rapidly during sketch upload as well as during serial communication, useful for debugging. 9. USB port, used for powering your Genuino Uno, uploading your sketches to your Genuino, and for communicating with your Genuino sketch. And number 10, reset button resets the ATmega microcontroller. So that's a quick look into the board itself. Other than the board, there are lots of other components. So since I don't have my webcam, I just created a list of components that are in here. So the first one is the battery snap. This is used to connect your 9-volt battery to the board. And then there is a breadboard. This is, a board that makes it easier to experiment with electronic circuits. So you can connect different stuff and disconnect them quickly instead of, bending your wires and soldering them or whatever. So this is very good for experimenting. Then we have some capacitors. Capacitors mainly store electrical energy and they release it. I guess like if the circuit's voltage is higher than what's in the capacitor, then it allows the current to flow in. And if the circuit's voltage is lower than what's inside the capacitor itself, then the capacitor releases the voltage, the charge that is stored within itself. So apparently this is often placed across power and ground close to a sensor or motor to help smooth fluctuations in voltage. So I guess it like regulates the voltage. Next up we have a DC motor. Oops. Right, something like this, but that's a servo motor. So we have some sort of a very basic DC motor in here. Then we have some diodes. Well, maybe I should explain what a DC motor is as well. DC, as you probably know, is direct current motor, so it converts direct current into mechanical energy. And there are coils inside. When current flows in through the motor, the coils are magnetized, and they attract and repel magnets, and they cause the shaft of the motor to spin. And if you reverse the direction of electricity, then the motor can also spin in the opposite direction. I'm not an expert, so I'm just telling you what I remember and also looking from the book, from the guide. So we have some diodes. Diodes make sure that the electricity only flows in one direction. So this is, I guess, good to protect your hardware. They're polarized. That means the direction they're placed in a circuit is important. As I mentioned before, if you connect it in one way, it'll let the current pass, and if you place it the other way around, it'll block the current. Apparently, the anode side generally connects to the point of higher energy in a circuit, so the plus. The cathode typically connects to the lower energy or ground, and usually the cathode is marked with a band. Okay, but this one these have bands on both sides. Next up we have some gels in different colors, and these just filter out different wavelengths of light. So if you can use it in conjunction with photoresistors, and then this way the sensor will only react to the light that is filtered, to the amount of light in the filtered color. We'll see how to use these in future examples. Then we have some H bridges. I don't know too much about these, so I'll just read it from the book. An H bridge is a circuit that allows you to control the polarity of the voltage applied to a load, usually a motor. The H bridge in the kit is an integrated circuit, but it could also be constructed with a number of discrete components. Okay, so basically a circuit that lets you control the polarity of voltage. Next up we have some jumper wires just to connect different components on the breadboard. Different lengths are available. And then we have some LEDs. I just show this. I just opened the yellow one here, but I think there are. Let me see. I can see yellow, red, green, and I think blue as well. So yeah, basically just like the simple diode, the LED, which stands for light emitting diode, also just lets current through in one direction. And if current passes through, it emits light. Of course, you know, LEDs also have an amount of voltage that they can accept, a maximum. So if you pass that amount, you might burn them. So we have to be careful about that. Yeah. The next component, there's an LCD. It's not this one because this one is Earth LCD and touchscreen. This is just an example, but the one in the box I think isn't touch. And basically it's a very simple LCD screen, a liquid crystal display screen. Yeah, it has 2 rows with 16 characters each apparently. So we'll learn how to program that. Next up we have some male header pins just to connect things, and these go into the female sockets on the board. Makes it easier to connect stuff instead of using wires, I guess. Then we have a piezo, which is an electrical component that detects vibration and can create noises as well. Then we have an opto coupler. An opto coupler apparently connects 2 circuits that do not share a common power supply. So inside this is a small LED, and when the LED illuminates, it causes a photoreceptor inside to close an internal switch. And then when you apply voltage to the plus pin, the LED lights, the internal switch closes, and the 2 outputs replace a switch in the second circuit. So it's basically like a switch, a connector switch, I think. We'll see how it works. The next component is a photoresistor. This is a resistor that has it's a variable resistor, and the ohm depends on the amount of light that falls onto this surface. So the more light it gets, the more resistant it is. The next component is a potentiometer. So this is like a variable resistor with a dial. It has 3 pins. Apparently 2 of them are connected to the ends of a fixed resistor. The middle pin, also called wiper, moves across the resistors, dividing it into 2 halves. When the external sides of the potentiometer are connected to voltage and ground, the middle leg will give you the difference in voltage as you turn the knob. Apparently this is also referred to as a pot. Next up is a servo motor. So a servo motor is a special type of motor that can only rotate 180 degrees. And yeah, this is like when you want to know the exact position of things. This is useful. The next component is a temperature sensor. A temperature sensor just senses temperature. It changes its voltage output depending on the temperature. Apparently the voltage on the center pin changes as it gets warmer and cooler. The one in my kit doesn't look like this. It looks more like a capacitor. Of course we also have resistors and push buttons, but they're pretty simple, so I didn't open a page for those. Resistors basically resist the flow of energy. Like I said, if you want to protect your diodes, you put the correct amount of resistors in front of them so that less current reaches the diodes, for example. And we also have some push buttons, just super basic buttons. They close the circuit when pressed. So if you don't press the button, the circuit is open. Next up we have a tilt sensor. This will open or close depending on the orientation. Apparently, usually they're hollow cylinders with a metal ball inside that will make a connection across 2 leads when tilted in the proper direction. So pretty mechanical, I'm guessing, or I mean, at least it sounds like that. And we have transistors. Transistors are 3-legged elements that can operate as an electronic switch. It's also used for controlling high current or high voltage components like motors. Basically, I think it's also just used to make sure that you're controlling your motor, well, that your motor is safe, I think, but I'm not sure why we use these transistors. Let me check what the guide says. One pin connects to the ground, another to the components being controlled, and the third connects to the Genuino. When the component receives voltage on the pin connected to a Genuino, it closes the circuit. Yeah, so just a switch. And the last component we have in this set is a USB cable. So that's about it. That's what comes in the package. Later on, so like I said, normally you can either install the desktop IDE, Integrated Development Environment. I think that's what IDE stands for. Or you can use the online Arduino web editor. So I opened that, and then I already installed the plugin. Oh, but it still tells me to download it. I already did. I guess now it's gonna... Okay, I never finished this process. I think it looked for it, I installed it, then it found it, and then I never finished the process. Let's see, it's supposed to, I mean, it should be able to find it, right? Because I have it installed. While we're waiting for this, so what we're going to be doing in our next video, we're going to be taking a look at our tools. So that would be the first section. This was just a short introduction. And with tools, I mean, like, we're going to take a look at the breadboard, what voltage means, and create our first like circuit. And yeah, when we're stuck, we can always look at sorry about that, at this video series. This is pretty cool. I think it has 10 projects. Yeah, the 10. Ooh, I'm not sure if these are all, these are the ones in the set, in the kit. Let me see. Number 10 is Zeotrope in my book, and this one is Twitter Controlled Mood Lamp. Okay, so these are additional projects, so that's cool. Well, this was supposed to work. Download. Looking for installed. Is there a way I can... How do I start? Maybe I should just install it again. No. Create agent. Okay, well, I'll get this running. Oh, maybe it already works if I just open the web editor instead of the install page. Right, there we go. Okay, it says no plugin connection, uploading disabled. Okay, so I'll get this to work. Make sure... Yeah, but what's the name of the program? Arduino? Yeah, look, I downloaded it 3 times and it's already here. Okay, I'll get this working and we'll continue with the second video next time. See you next time. Take care.